This is an exam review video for the spring 2024 semester. And so basically what we're going to do is we're going to work through last semesters, which would be fall 2023. We're going to work through their exam too. And so basically this is a review for exam 2 for spring 2024. And so what I want to emphasize on this video is that just watching this video or just working through this old exam is not sufficient to study for your exam. So you should also make sure you review your notes, and for each section maybe pick out what are the important theorems or results from that section, what types of problems appear in each section. You also should probably review your online homework, and then if you had any quizzes or anything else like that, you make sure you review those problems and that you're able to do the types of problems that appear on the online homework and in your class notes that you took in class. Okay, so let's take a look at the first one. So it says that I have some function L of x, which is equal to f of 6 plus f prime of 6 times x minus 6 represent the linearization of some function at 6. Which of the following guarantees that L of 6.5 is greater than f of 6.5? So what I have here is I have some function where at 6 I have my f of 6, and so my function is doing something, I'm not sure, and then I have a linearization, which would be the slope of the tangent line. So what I want is that the line at 6.5 should be greater than f of 6.5. So what I want is that at 6.5, the line is on top of the curve. So basically what that's going to require is that the function is concave down. So that could happen whether or not the function is increasing or decreasing. Basically all we need is that the function is concave down. Then the line will be on top of the function. So what I want to circle here is that the function is concave down. So that would mean f double prime is less than 0 for the function between 6 and 6.5. So that's what we would need to happen, is for it to be concave down for the line to be on top. Okay, for the next one, I know that f is a twice differentiable function with critical points at 2, 7, and 15. So what that means, a critical point is where f prime could equal 0. So that is at 2, 7, and 15. Okay, and then I have some information about f double prime as well. I know that it is negative on the interval from negative infinity to 4. And I know that it is positive from 4 to 7. And I know that it from 7 to 13 it is negative. And I know that from 13 to infinity it is positive. Okay. All right, and so then it asks, what is a global maximum of f? And so on the interval from 4 to 13. So when I think about this, I know that it has a critical point at 2. It's concave down there, so that means that 2 is a maximum. So we have a max at 2, some kind of a local max at 2. And then at 7, we know that it changes concavity at 7, so we're not quite sure what happens there. Then it is, at 4, it's concave up. And then at 7, it switches to be concave down. And then at 13, it switches to be concave up. So we know that 15 is a local min. This is probably neither. Okay, so so we know that there is a local max at 2, so it could be going something like this, and then having a local min. So I would say that there is a local max at 2, at f of 2. That's the only one that has a but that doesn't seem to be the answer that's here. So what's the deal? What am I missing? Oh, look at that. Okay, so yeah, 2 would be the maximum if it was the whole thing, but it has this interval from 4 to 13. So the biggest one's going to be at 4. So the maximum actually happens. So this is at 2. This is at 4. It's concave up, but it doesn't go way up because I don't have another critical point, and it has an inflection point at 7. So the max is going to be at 4 at the end point of this interval. So that's the solution. Okay, so for the next one, given that f prime of -4 is 0 and f double prime is 2 sine of pi x, which statement is true? So, all right, so I know that f prime of -4 is 0, so this means that -4 is a critical point of f of x. So it's a possible max or min or maybe an inflection point. So what I want to do is I want to check by the second derivative test, I want to check what is f double prime at 4. So it's going to be 2 sine of 4 pi. Well, if you plug that into your calculator and you're in radian mode, you're going to see that that's going to give you 0. And we can also think about the sine function. That's going to well, we're basically having something like this, that when I plug in 4 pi, so at 2 pi it's at 0, and then it repeats again, and at 4 pi it's back at 0. And then this 2 just stretches it vertically. So we have that f double prime equals 0 there. So it's not a local max or min. It ends up being an inflection point. So for it to be an inflection point, we actually need to check that it changes signs. So if I think about the graph here, I can see that it's negative to the left and positive to the right. So it does actually change concavity there. So that ends up being positive. A lighthouse located on a small island 3 kilometers away from the nearest point on a straight shoreline. Okay. X is the distance between P and the intersection with the shoreline. Let theta represent the measure of the angle. Okay. Which formula defines the relationship between the rate of change of the angle's measure and the rate at which the beam of light is moving along the shoreline? Okay, so what we have here is we can go ahead and define a trig function here. So we know that tangent of theta is equal to x over 3. And if I take the derivative of that implicitly with respect to t, I'm going to get secant squared theta times, and I need to do the derivative of the inside because theta depends on t, so I'll need a d theta dt. That's just by the chain rule. And then what's the derivative of x over 3 with respect to t? Well, it's going to be 1/3, and then the derivative of x with respect to t is just dx dt. Okay, and so it should be b secant squared theta d theta dt plus 1/3 dx dt. Next, suppose that the function g of t equals 6t squared minus 0.75 t cubed represents the height of a golf ball above the ground, t seconds since the ball was struck. By solving which of the following equations can we determine the value for t which the height was maximized? Okay, so I can see that this is giving us a function with respect to height, and so I want to find a maximum height. And I know that a maximum height will occur at a critical point. And a critical point happens when g prime equals 0. So if our function g of t is equal to 6t squared minus 0.75t cubed, and I want to take the derivative of that. So I'll have 12t minus 0.75 times 3t squared. So if you multiply 0.75 times 3, you're going to get 2.25. So it should be that, and I want to set that g prime of t equal to 0 to solve. So this is what I want to solve. So that is part D.